So let's take a look at writing the delete last node using recursion. And so before I do that, I want to just take a quick look at our client program or our test code. And so when you're running this program, you're going to want to set up different scenarios, right? Like I have 3 different nodes and I'm going to delete the last node. Well, what happens when I have no nodes, or if I only have 1 node? So then you can just change your test program to accommodate for those test cases. So that's what we'll do in this client or test program. So here's my linked list I've set up, 5, 3, 2, right? I've added that. And then let's go look at the recursive code. So when you're doing a recursive function, you have to pass it head, because how this is going to work is the first time you call the function, you're going to pass it this list, the entire list, 5, 3, 2. You'll look at head, and if head next pointer is not null, you know that we still have to break down the problem, because we're trying to get to this part right here. We want head just to have 1 element, because that's going to be one of our base cases. We know what to do when head has 1 element. We just delete it, and then we set head to null pointer, right? That's what we did in the iterative solution. Since this is not null, I'm going to break down the problem, and I'm just going to send those 2 nodes, and this will be the new head. Well, head's next pointer is not null, so I still need to break it down further. So I'll break it down and I'll just send this node, and that'll be the new head. And then when I look and I see, oh, head's next pointer, well, that's null. So then I know I'm at the end of the list. I can remove it, and then I can start to unwind. So what is all this unwinding about? Well, let's check it out. One thing you have to know is, since this is going to be an abstract data type, you do not have access to head, okay? And since that solution that I just walked through requires a new head each time, I'm going to have to pass it head to the function. Well, I can't do that in my client program, right? I can't pass head because I don't have access to head. Head's a private member. If I go look at my interface, you can see that head is private. Okay, so can't access that. So what we're going to do is create something called a wrapper function. And what a wrapper function is I can call this function, which is public. Okay, it's public. And then I'm going to overload that with a function that's private, and I'll be able to send it head. So if I look at that implementation, here's the wrapper function. So when this is called, I'm just going to call that private function, has the same name, different parameters, so I can do that. That's method or function overloading, and I can pass it head. So then up here, I'm going to pass it head. And I want to pass head by reference so that I can update head in the function. Okay, so that's super important. You'll see that in a moment. So what are my base cases? Not return 0, but what are my base cases? So if there's no head, I'm done. Or if there's 1 node, then I'm done, because that node's next will be null, right? And so those are the 2 conditions that will cause us to be done. We have found what we're looking for. We've broken the problem up into small enough pieces, or a small enough piece that we can say we're done. Okay, so if once we come across a node, a head, that has null as the next pointer, we can delete that, set it to null, and then return. If it's not, we are going to call the function again, but this time, instead of passing head, we're going to pass heads next. So we only are going to pass this part of the list, 3 and 2. Okay? And when you do this, you are starting to use the stack for function calls. So every time you call a function, a copy of that function is put on the stack with all of the local variables. So the first time I call this recursive function down here, it's a copy of that function is put on the stack. So it looks something like this, right? And so this has one local variable head, which is passed by reference. So it's really an alias to head. Okay, so it's actually contains that same address that head does because it is head. I don't return here, I don't return here, so now I'm going to call the function again, but I'm going to pass head .next. So this is the first call on the stack frame. So when I call it again, the whole function is put on the stack. This is the second call. And it has its own local variable, head. But this time, it's past this address, right? So that head in that instance of the function call is holding the address right here in that pointer variable. And so when I say over here, is there no head next? Well, let's see. There is a head next. It's right there, right? It's not null. So then it's going to call it again. This is the third call. And its head is that address. So it's going to say, is there a head next? Nope. You can see right there, there isn't a head next. It's null pointer. So what do? We delete the head. So we delete the head. And we set head to null pointer. So head is right here, right? That's where it's pointing. So head gets set to null pointer. And we didn't need a previous variable, right? We didn't need a previous variable because the recursion automatically takes care of that. And then we return. So when you say return, what you're doing is you're popping this off the stack. And it returns now to this instance right here. So now we're in the second call. Well, what was head pointing to in the second call? Well, head was an alias for this memory location, which contained an address to this node right here, right? And so when it returned, we are right here, right? And it's just going to go to the next line, which just returns out of this function. So then that's popped off the stack. I'm now at the first call. I return right here. This is where I am. I'm going to the next line, which returns out of the function. So it pops off. And where does it return to? It returns to wherever it was called, which is right there.